So enough with these crazy videos. There's a reason I showed that last video, as you could probably hear in my voice. I'm losing my voice. I've been on the road for the last 3 weeks presenting to various conferences around the world on SQL Azure, and at the end of a very long road, the voice is about to go. So I have plenty of water. I'm going to try to relax the voice. I have a customer who's going to come up and give my voice a break for a couple minutes during the presentation. So hopefully we'll make it through this. So good morning. My name is David Robinson. I see a lot of familiar faces to you out here in the crowd. So hello, good to see you again. I see some new faces, so it's good to meet you. Today we're going to talk about scaling out web applications with Microsoft SQL Azure. It's also interesting that we had this video, and the song was, "It's time to change." And when I think about it's time to change, I think about it's time to change how people think about databases and about how they scale their workloads. And I think it's time to change how we approach scaling something. And the change, and what we're going to be talking about today, is around scaling out. Not about scaling up, but scaling out across multiple databases. We've heard things about the 10 gigabyte database limit. Why is it? What is Microsoft doing? Why 10 gig? The good news is that number will be going up. We had a futures talk earlier in the week, which we talked about some of that. But at the same time, we still, you don't want to run a 1 terabyte database on a commodity-based server. It doesn't have all the resources and the other capacity besides disk storage. It doesn't have the required memory. It doesn't have the required CPU resources to really do your workload, the justice it requires. So we're going to be talking today about scaling out. Let's get started. So quick overview of the session. We're just going to go into a brief SQL Azure recap. Just one slide. I'm not going to sit here and go through the whole entire life cycle with you. I'm assuming that if you're coming to this talk, you've already heard a lot about SQL Azure. We're then going to talk about why people scale workloads. We'll look at some different application scaling techniques. And then we'll have some considerations, things you need to really think about and worry about when you go ahead and you approach scaling out an application. And then we'll talk a little bit about some of the future stuff that we're adding with integrated scale-out support. So here we are. Excuse me 1 second. You'll notice I'm going to go frequently to the water, so I apologize. So for those of you who were in here before the session started, we had a nice video showing pretty much all the different value props of the SQL Azure database. It's being rumored that I'm actually going to be replaced with a stick figure sometime in the future, so this might be my last presentation, but hopefully we'll get through this together. Good thing is I don't think stick figures lose their voices. So as you can see here, SQL Azure is a highly scaled out database as a service. And the point I really like to point out to people is the as a service part. As a service, that carries a lot of weight to it. So when we say as a service, meaning part of the service is we worry about disaster recovery. Part of the service is we worry about backups. Part of the service is we worry that if something should happen to some data inside one of your databases, we have backup replicas that get promoted automatically to primary. So as a service, it's not just database hosting. And if we look at the different value props, self-provisioning and capacity on demand. So what does that mean? That means I can walk up to the service right now, I can create a new server, I can create a new database in about 10 seconds. I don't need to go out and buy a license. I don't need to install it on a box. I don't need to wait and go through this whole process. We also say that we have symmetry with the on-premises database platform. I have a talk a little bit later on around future database development. And in that talk, I'm actually going to take a database that I have running locally. I'm going to move that up to the cloud. And then if I want, I could take that database, I can move it from the cloud back on premise. I'm not locked in. I have full symmetry. I can go back and forth. And once again, we also have automatic high availability and fault tolerance. If we save multiple copies of your database, if something should happen to one of them, we automatically take one of the backup copies and promote it to primary in a matter of seconds. Typically, you won't even see any service disruption. And then finally, simple, flexible pricing. Later on in the talk, we're going to bring up one of our customers who's going to talk about how they're very on a day, they'll spin up many different SQL Azure databases just because they need to meet a high capacity peak, and then they scale it back down. And they only get charged by the day. So this flexible billing model enables us to really offer you, supreme value in the platform. So let's think about why people scale their applications. And this is nothing new to people. People typically scale their application to increase an application's ability to process and store data. Okay, makes sense. And usually it's because of heavy resource consumptions. The workload might increase. You might have additional CPU requirements. You might have additional storage requirements. You might have architected a solution and thought, oh, this is going to service 1,000 users. And then all of a sudden you become the next Twitter and you have 5 million users showing up at your door. And you need to think about how you're going to go ahead and scale that application. So what's built into the service today as far as scale-out support is concerned? Automatic, database and workload partitioning, classic way of addressing these scenarios. Levels of throughput, that's not able to be consumed on a single machine. With SQL Azure, you now have the ability to spin up multiple databases. And with that, with the highly available service, zero administration cost, you have access to an elastic pool of resources, and once again, it's pay as you grow. There's no friction. You can spin up databases literally in seconds. I'm going to keep saying that, and I want you guys to walk out of here saying, wow, that guy thinks you can spin up databases quick, and you can. And once again, you can keep creating these databases and keep creating these databases without running out of capacity. Earlier in the week, at the keynote, we talked about Kelley Blue Book. Kelley Blue Book was one of our first TAP customers, and they provide vehicle valuation data. I'm sure all of us have been out to their website. They get 13 million hits a month, excuse me, I wish. 13 million hits a month. They have a 2.5 gigabyte database, and what they do is they refresh that data set once a week. And the reason they've gone ahead and they have 5 different copies of this database is because they need the capacity of 5 CPUs, and they need the resources of 5 sets of memory. So they're able to, when their application and it comes in and it connects, it actually does a round robin. And it'll actually go ahead and randomly pick a database to connect to. And if they see their hits go up to maybe 30 million hits a month, all they need to do is increase the number of databases and increase the number of times they spread this load out. And once again, like I said in the bottom point, they can increase and decrease the database count based upon demand. Pretty simple stuff. I know it seems complicated, and some of the topics that I'm going to go into later on in the talk, they are complicated. And I have a tendency of making it seem like some of the stuff is easy to do. Some of the stuff is not easy to do. It can be difficult. We'll be going into source code in a little while. And with that source code, we'll be taking this source code and putting it out on CodePlex later in the week, so you guys can actually download this and use this as a starter kit, for applications that you might have of your own. Let's look at another real-world scenario. Company called Ticket Direct. And Chris, you want to come up and join me? So here's Chris Auld, Director of Strategy and Innovation for Intergen.
How you doing, Dave?
Hey, dude. What's going on?
We've got audio up. Good morning. How are we, everybody? So ticketing's a really hard problem. Who likes going to sports matches? Who hates sports like going to cultural events? Right? So ticketing's interesting because when you think about ticketing, it's really moving to the web, right? No longer do you spend your time rocking up to the box office to buy tickets as much as you would in the past. You may occasionally buy one from a guy on the street corner here on Figueroa. I had a few offers to go to the hockey last night, but as a general rule, you're going to be buying your tickets through a web browser. And when you think about what it means to be a ticketing company, it's a very difficult problem to solve. Because most of the time we're selling a few hundred, if we're lucky, maybe a few thousand tickets per hour. When we put a really popular event on sale, we're going to be selling a couple of 100,000 tickets. Probably we could sell them in 3 or 4 minutes. Literally, that event goes on sale 9 o'clock in the morning. From about 8:30 that morning, we have.
So Chris, if you were going to sell tickets to like my presentation,
Absolutely, Dave. I mean, we had people knocking at this door from about 9:45, right? So literally, we're going to drop this event on sale 9 o'clock in the morning, 8:30 in the morning, people are hitting F5, trying to get in and hit our event. And of course, selling tickets is actually a high data integrity problem, right? We can only put one backside on each seat, right? And when you sell tickets, you want to do things like sell groups of tickets together. When you buy 5 tickets to go to the hockey with your friends, you actually want to make sure those 5 seats are together. So the folks at Ticket Direct have built up over time a bunch of intellectual property in SQL Server stored procedures for the high performance, transactionally consistent fetching of these blocks of seats. But of course, that scale is the problem. We need to be able to go from a low scale scenario most of the time to a really high scale scenario for a very short period of time. And for us, that's really all about scale out. Scale out's never going to work for us, right? Because scale up just means we've got to buy a ginormous server and have it sitting around doing absolutely nothing most of the time. So instead what we do is we thought about partitioning. Now, how do you partition, right, to get the best out of a ticketing scenario? And we are uniquely lucky, ladies and gentlemen. We have a beautiful, natural partitioning scenario.
Excellent.
Right, so what we do is we say, we've got a sporting venue that's got some stands. In each stand, we've got some sections. In each section, we've got some rows of seats. And literally, we can partition down using these natural structures within our venue. And we only need to partition up for a short period of time. So we partition for performance, right? So 2 o'clock in the morning, big game's going on sale. We actually take that game offline. We run a Windows Azure worker role called our partitioner worker. It runs around with the SQL bulk copy client and ADO.NET. We chop the database up. We chop up currently into about 100 partitions per venue. We bring the application back online, and we have in our cache information on how to resolve the appropriate partition for the particular sections in the ground. We then sell out that event very, very quickly, and then the following night we departition that database and consolidate all our information back into one database. Right? We are partitioning for performance reasons. We're having lots and lots of SQL Azure instances because we need lots and lots of CPU, lots and lots of I/O throughput, and a good chunk of memory to really make this thing hum.
So those databases live for a day.
Those databases live for one day.
So you're being charged 100 times 33 cents.
Yeah.
Wow.
Yeah. If it turns out actually 100 databases isn't enough, we'll spin up 1,000 databases. Don't worry me too much, right? Literally, we have just insane amounts of computing power at our hands now. Right? We can build the fastest ticketing system in the world. I mean, you will not tear down our application because we can scale out enormously, right? And we can do so very, very cost effectively because we're only paying for what we use. I mean, this is totally revolutionary. This would be absolutely unsolvable any other way.
Excellent. Well, thanks for joining me.
Thanks, Dave.
Take care.
Great. And I'll be back for some questions later if people have questions. Yeah. So
perfect.
Be good.
Thanks, Chris. It's always good to get a customer to actually come up and talk, because a lot of times I feel that when we give these presentations, people look at us and they're like, you know what, you're painting this pretty picture, you're telling us about all this great technology, but it's not really usable. There's no scenarios that it applies to. So it's great to have customers come up and actually say, hey, this is what we did and this is how we did it, and to validate it for us. So let's start thinking about what our application's requirements are. And we have 2 axes here. One has to do with what the transactional requirements of your application are, and one has to do with what the storage requirements are. And we can see we have low and high on both axes. And we think about applications that live in the bottom left-hand quadrant of having low transactional requirements and having low storage requirements. And those applications, typically they'll sit on a single database, whether it's a 1 gigabyte database or a 10 gigabyte database, and they don't need to partition it. We have a lot of customers, when we had first thought about the web and departmental applications, we saw there was a lot of applications that lived in that bottom quadrant. We also have applications that have high storage requirements but low transactional requirements. And what we typically do there is we partition our data. And typically, the applications that live down there, they're typically like archival type workloads. And they use typically some sort of ranged-based partitioning scheme. And we'll talk about some more of that in a little while in the talk. And then we have applications that live in the upper left-hand quadrant that have low storage requirements, but they have high transactional requirements. And Ticket Direct sits up there in that upper left-hand corner where they don't need to store a lot of data. They just need massive amounts of CPU and massive amounts of I/O to be able to service their workloads. And then on the right-hand side, we have just craziness going on. We have high transactional requirements and high storage requirements where these are mega-scale applications. So I recommend that people, all you guys, when you walk away, keep in mind this slide, maybe download the slide deck and really think about when you're going to take an application and either move it to SQL Azure or you're going to create a new application and target SQL Azure. Think about where your application is going to fit, because that's really going to determine the decisions you make when you approach some sort of scaling pattern. So when we talk about scale-out patterns, there's multiple standard scale-out patterns. This is nothing new. This applies to SQL Server on-premises. It applies to SQL Azure in the cloud. It also applies to databases like Oracle and IBM. This is common stuff. And typically, we think about two very common patterns. Number one, ranged-based partitioning. And what we do is we take our data and we break it up into chunks. And ranges can be variable in size. And they're good for ranged-based queries. Archival workloads are typically ranged partitioned. But the problem is depending on the workload, if you're doing some sort of let's say you're doing some sort of sales forecasting, and you're doing it based upon month. At the end of the month, and when you got to do your roll-ups, that partition may become very, very hot depending on how you partitioned it. So just keep in mind that typically ranged partitions, they can suffer from hotspots. Another partitioning scheme that we think about is hashing. And we come up with some sort of hashing algorithm, we apply it to some sort of key, and it gives us back a value, and that will determine where we go ahead and store our data. And this is really great for distributing values. So if I want to evenly distribute my load across a lot of different databases, hashing is a really, really great way to do it. The problem with hashing is that it's really poor for range queries. It requires a full fan out. So if I want to go ahead and let's say I'm partitioning based upon customer ID, and I've hashed my customer ID and I've spread them all out across 100 databases. If I need to go out and say, okay, show me every customer in the state of New York, I would have to take that query and issue it to 100 different databases, pull those results back, aggregate them in my middle tier, and then return them to the caller. And we'll actually go into how to do fan-out queries in a little bit, but it's something that you really need to consider. And the other issue with hashing is that you need to accurately estimate your workload requirements. So one of the things we'll talk about in a few minutes is, what are the best practices? What is the guidance? How can I go ahead? If I go ahead and I say, okay, I'm going to hash partition my workload, what about if it fills up? And so one of the things we'll talk about is, maybe you should think about using a hash partitioning scheme and use 1 gigabyte databases. That way you have the ability to move up to a 10 gigabyte database if the need requires. But we'll get to that in a moment. So this is our scenario. Fabricam is a world-renowned company, and now they're selling fish, actually. They're an online reseller of exotic aquarium and pond fish. Their peak sales periods are from November to December and May through July for the holiday season. And in May and July, they sell a lot of pond fish. And they have 726,000 different varieties of fish. And we'll actually go ahead in a second and look at some of these fish. And if we look at Fabricam's schema, we've actually broken it up into 2 separate pieces. We have the product schema and we have the customer schema. Right now, we're going to look at the product schema. And the product schema, just like the Ticket Direct scenario, lives in the upper left-hand quadrant because they don't need to store much data, but when orders are coming in, the stock table can become extremely hot. So we need to be able to spread that load out and have multiple machines and multiple CPUs being able to handle that load. So in our scenario, we've range partitioned it, and we're utilizing 1 GB databases. So actually, let's go out and take a look at some code now and jump into Visual Studio. So let's get out of here. Let's actually tab that, escape out of there. So what we've done here is, and I'll zoom it in a second. Let's put that up there. Let's go out into my bestest friend, SSMS, and connect up. Here we are. It's thinking about it. So what we're going to do in a moment is we're actually going to see the server where all these databases are located on, and we'll actually be able to see the different databases for each one of these workloads. That's if oh, there we go. That's better. Okay, so let's take a look here once this finishes expanding. And I apologize, the conference center networks are typically not as good as we would hope they are. Let's give this one more second. One more second, and if not, we'll move on. All right, let's move on for a second while that's continued to expand. So what we've actually done here, let me move over here, is we have a data set of, actually I want to move up a little bit more. Let's go up here. God darn it, there we are. So what we've done is we've taken our product database, and we've taken that schema, and we've installed it across 14 different databases. And the reason we did that is because we wanted to have more capacity, for when those orders are coming in. And the way we went ahead and loaded this was to make sure that we have lots of interesting data, is we created a new data table, as we could see here. And we've added all the different columns to that. And then if we scroll down, we just go into a loop. Let's look here. We go into a loop. And this may or may not be a good way to do this. And the reason I say that is we just wanted to go ahead and get as much data into the system as possible. So what we've done is we have a table of fish, and then we go ahead and we take each fish, and we have a table of colors, and we have a table of sizes, and a table of sex, and a table of ages. So we're just using this to populate tons and tons and tons of data into the system. And the other good thing about this, as Chris mentioned, is we're actually using the SQL bulk copy API to import this data. Let's pull that up where that happens. There we are. So there's the actual SQL bulk copy API. So we're opening up a connection. We're saying our destination table. And what we're doing is we're looping over every partition, every database, and we're just jamming those records in. When we had originally run this and started working on these patterns a few months ago, before we actually had SQL bulk copy support, these things were taking 20 minutes, a half hour, an hour to run. It was taking so long. With the bulk copy API, it now takes 30 seconds, 45 seconds, because it just opens up the database and just crams it right in. So for anybody out there who's actually doing any sort of data load, use the bulk copy API. I can't stress that enough. So that does our data load, and if we actually go out to the site, and I'm sure all of you will once you see what the URL is, it's fabricamfish.cloudapp.net. Let's go out there. And once again, I apologize for the speed of the network here. And there we go. Let's go back to SSMS just for a moment so we can see all of our different product databases. And once I expand this, I'll zoom it in for you if it decides to expand for me. There we go. So notice we have a single table in here. And if we look at product 2, so the schema for both of these tables is exactly the same. We've just gone ahead and we have multiple copies of the same schema, but we have different sets of data based upon the range we've chosen inside those tables. The range scheme, the range partitioning scheme that we've chosen is to range based upon the fish family. So if I look here, I have a whole bunch of different fish families I'm not a marine biologist, so I really can't tell you what the genus of all these different fish are. But it looked kind of interesting for demo purposes, so we went ahead to go to use it. So if I go here and say, select a specific fish, and I do a query, what's going to happen is it's going to look at that fish family. It's going to figure out which partition to go to, and it's going to direct that query directly at that partition. So let's go ahead and give that a try. So let's go ahead and pick that. Give it a second. It's going to go ahead and load up all the fish. So let's go ahead and choose, I don't know, a bowfin. Ooh, bowfin. So let's go ahead and do search. So now it's directing this directly at that single partition. And in a moment, and we actually have on the right-hand side of the screen, we have the rows, execution time, and rows per second, just to show you not from the slow convention center network up to Azure, but to actually show the interaction of the database if you were on a real network. And this will actually show you the round trip time from Windows Azure to SQL Azure and back again. So let's give this one more second. One more second. Oh, I love convention center networks. So who went to the was it a hockey game last night? Everybody went? Yes? No? So, yeah, let's, you know what? Let me go ahead and click search one more time. Maybe it's a little upset with me. How about that? Oh, look at that. All I needed to do was click search again. It was getting a little finicky. So what we just did was we took a single query, we directed it to a single partition, we pulled back 1,000 rows, the execution time was 0.3 seconds, and the rows per second was 2,700 rows per second, taking a single query, single database. Now I'm actually going to do this other query. I'm going to do a full fan-out query, and I'm going to pull back every single product we have. So what's going to do is it's going to say, select all from every database and pull it back to me. It's then going to take that stuff, and it's going to aggregate it on the middle tier, present it to me, and it'll page it in as I click next and next and next. But the reason I'm going to go ahead and do this, let me just go ahead and click that and let it start. The reason I want to go ahead and do this is because I want to illustrate that if you go ahead and you use a fan-out query, and you use multiple machines, and you do these things in parallel, how much data you can actually process in such a short amount of time. And this typically takes, well, in my hotel room, it was taking about 15 seconds. In this network, I don't know how long it's going to take. So let's just give it another second. And while that's running, let's actually go ahead and look at the fan-out query pattern. And if I go out to the fish UI, and here we are. And what we basically do here is for every database that we know of, we go ahead and we issue this query. And when all the results come back, we take the results and we actually merge them all together. And we show that here. And once again, all this code is going to be posted up into CodePlex. And then that's showing the merge right there. So we actually take all the tables and we merge them all together and we return them to the caller. So I recommend everybody download this code and take a look at it and see how it works. Run it for yourself. When you run it locally, hopefully you'll get better results than I have. But now that we've seen that it came back, we pulled back from SQL Azure into our middle tier 726,000 records. It took 25 seconds, and I'm actually going to run it again just to see if we can get a better time. But even at that, even at 25 seconds, it was doing 28,000 rows a second, which is actually pretty good throughput if you think about it. Because we've harnessed the power of multiple machines. We've harnessed the power of multiple sets of CPU and IOPS, to go ahead and get better performance from our application. So let's give this one more second. And we'll actually come back to this because I have a feeling it's going to take some time. And let's go back to the slides. So we've talked about the product. Now let's talk about the customers and the orders. What we need to do with that is we need to evenly distribute our load across multiple databases. We've hash partitioned it based upon the customer's email address. And what we've done is we've started with 1 gigabyte databases. And the reason we've done that is that, I'm a program manager for Microsoft. I don't know if I can accurately calculate how much space I'm going to need for my fish store, So I'm going to start with the 1 gig databases. As we spoke about in the future session, very shortly you're going to be able to go and take that 1 gigabyte database and move it up to a 10 gig database, or move that 10 gig database back down to a 1 gig database with just a simple command. So this gives me the ability to go ahead and say, okay, I'm planning to be able to store X amount of data, but if for some reason, my fish store becomes the next Twitter, like I said earlier, and I need to store massive amounts of data, I can then go ahead, switch those over to 10 gigabyte databases, get past, that initial bump in the initial capacity requirement increase. And then if it's going to be sustained, I can think about maybe I want to re-engineer the way I've done my hashing. Or maybe it was just a peak load and I can archive some of that data out and then move it back down to 1 gigabyte databases. But that's something you need to keep in mind. You really need that flexibility. I'm actually going to have to start speeding up a little bit because we're only got 28 minutes left. So let's look at the customer implementation. And did this come back? It did, but it came back even slower. So we're gonna leave that alone for the time being. And we go back to the data loader. Let's look for begin load customer data. Let's zoom into that. And let's see what we're doing here. Okay. So once again, we're creating some random customer information, and we're setting up a customer object and setting all the properties of that customer object. We're then creating some random number of addresses. We're then calling into this function called getCustomerDB. And let's actually look to see what getCustomerDB does. So getCustomerDB just returns this formatted string, but it's calling a method on the customer object called getInt64 hashcode. So let's look at that very quickly. And it's just a pretty rudimentary hashing function that we're doing here. We're just taking the MD5 hash and stripping off the first 8 bytes. And we're using that as our hashing algorithm. And that gives us all of our customer data. So now that we've taken and with this hash algorithm, we have evenly distributed all of our customers over all the available customer databases that we have. Let's go back to the slides. Get some more water before my voice. Okay, so this is the part of the talk where we start talking about what you need to think about if you want to go ahead and do something like this. And there's 4 different considerations: schema design and management, reference data, request routing, and fan-out queries. So let's jump in. So schema design and management. Schema design should avoid cross-database joins and transactions. Those are very difficult things to do. Today in SQL Azure, we do not support distributed transactions. If you want to go ahead and do these transactions cross-database, and you want to have them be transactionally consistent, you need to manage that yourself. That is something that is difficult to do. So that's something you need to keep in mind. We also say that DDL should be upgrade resilient and item potent. So what does that mean? That means if I go ahead and I rerun an upgrade script or a schema install script to one of my databases, and it's already at a certain level, I shouldn't have to worry about anything destructive happening to my schema. And then your application code, and this is something we had to work really, really hard on the SQL Azure team, is to make sure that we can do these in-place upgrades when we go ahead and we make changes to our system so that you don't experience any downtime. So what you guys should think about is to be able to support either multiple schemas during an upgrade or stop processing requests during an upgrade. In our case of SQL Azure, we don't have that luxury to stop. Say, okay, everybody, stop sending transactions for the next 2 hours so we can go ahead and upgrade the system. So it's something really important to keep in mind. And this is just a really easy, simple snippet of code showing resilient DDL. And basically, we're only going ahead to create the table if it doesn't exist. Pretty simple stuff. And then we also think about request routing. Your application needs to be partition aware. A partition or a database, in our case, is the unit of transactional consistency. Each partition in your system is independent of one another. We need to use some sort of function to locate the partition. Just like we showed a couple minutes ago, where we used the getCustomerDB function, which called into our hashing algorithm to figure out where to go ahead and put the customer data. It's something you need to think about. And I'm sorry if I'm speeding up. We're just going to run out of time very soon. Reference data and synchronization. There's certain pieces of reference data that most applications have. And if you've gone ahead and if you've partitioned your workload, let's say you've partitioned your customers, like we did in our case. There's certain reference data, like zip code tables, that we need to go ahead and to avoid cross-database joins, we need to have that data, live inside multiple databases. So what we do is we replicate the reference data for performance reasons, because we don't want to go ahead and do those cross-database joins. So how do we keep this replication and this data in sync? Well, we have two options. Number one, sync framework. This thing works great. We actually have a download that we announced on Tuesday. If you go out to windowsazure.com and click on the SQL Azure tab, you can actually download this little widget that plugs directly into SSMS so that you can set up a synchronization between your on-premises database and the cloud. So sync framework, really, really great way to accomplish this task. Number two, manual update scripts. We see a lot of people doing this today, where they go ahead and they say, okay, the new data load for the product catalog came in, and they go ahead and they give it to operations, and they go ahead and they do the load. But one of the things you need to ask yourself is, how often are you going ahead and doing these updates? And if it's happening very, very often, is it really reference data? So take that and take a step back and say, hey, if I'm doing this load every 6 hours, maybe I should think about re-architecting my application a little bit. I should have renamed this slide, fan-out queries on a decent network. So with a fan-out query, you issue query to multiple databases in parallel and aggregate the results. It's not that difficult. But to get the best performance, use multiple connections and multi-thread your calls for increased perf. This is useful in many scenarios. We see customers that partition their workloads. They have certain sort of back office functions like reporting and things of that nature, or some sort of archival and BI capabilities where they need to go ahead and do these fan-out queries. All right, so we've said a lot, and right now, if I've done my job well, I've showed you that at any conference, no matter where you are, your demos will not work as well as they do in the hotel room, number one. Number two is you should have learned that there's a lot of things that you can do with SQL Azure, but some of them are a little difficult. Things like managing your schema and managing your reference data, fan-out queries, things of that nature. You can do them today, and we have a lot of customers that are, but the good news is that we know that some of these things could be a little bit more easier. So what are we doing? We're going to be offering better tooling for developers and administrators, and we're going to be offering dynamic database partition splits. So that if you have a single database and you want to go ahead and split it in half, you're going to be able to do that. This is coming, and Tony talked about a lot of this in his talk, in his futures talk on Tuesday. So this is coming. On the contrary of that, if you have two databases that are being underutilized, you'll have the ability to merge those into one another as well. And improve schema management across database partitions. It kind of completes the suite of database partition splits, database partition merges, and keeping the schema accurate across all those partitions. Secondly, things we're coming out with is specific features for scale-out patterns. Connection management, so you don't have to constantly, run these hashing algorithms and connection management features so that you know where to go ahead and connect to get your data. And we're also building in fan-out query support into the system. So that way, if you want to go ahead and target a specific partition, or if you want to go ahead and target every single partition, we're going to be doing that in the service for you, so you don't have to worry about managing that in your application. So, in summary, we covered a bunch of stuff. We went over a brief SQL Azure recap, relational database as a service in the cloud. We talked about how scaling provides virtually unlimited storage and better performance when you're not running on a convention center network. We also talked about range and hash scale-out patterns and how not only do they apply on premises, but they also apply in the cloud, and it's nothing new. This is all, kind of standard stuff. We learned about things we need to think about when we're scaling out, and those things are schema design and management, request routing, propagation of reference data, and also fan-out queries. And we also talked about the future scale-out support that we're building into the service to make a lot of these things easier for you. The good news is that if you start building with SQL Azure today, all the patterns and practices and the guidance that we're providing you on these topics, we're taking those into account when we build these new features in. So if you go ahead and implement a system such as we described today, and as documented in the code we're putting up on Codeplex, if you go ahead and implement such a system, all the things that we've implemented in there will be compatible with the new features that we're coming out with. So we don't want you to feel that if you go ahead and go down this road today, hey, SQL Azure is going to make this stuff easier for me, and I'm going to have to throw away all this stuff. You're not going to have to throw away all the stuff. You're just going to probably have to comment out, a bunch of code and just replace it with a single call to the service. We have a bunch of other upcoming SQL Azure sessions today. We have the SQL Azure database under the hood. Jeff Currier, one of our development leads, is giving that talk in this room right after me. This is a great talk. If you guys were at PDC last year, one of our architects, Gopal, gave a under the hood talk on the actual back-end layer. Jeff's going to be concentrating on the front-end layer and how your transactions flow all the way through the system. If you're wondering how it works, this is a great talk to go to. And then later on in the day, I'll be giving a future of database development talk with SQL Azure in this room as well. We'll be looking at some new tools enhancements that we've been making. We'll be making an announcement about a new product we'll be coming out with. And then finally, later on today, will also be a session given on the Microsoft Sync framework and how you can take that and connect apps to the cloud. And he'll be showing some of the stuff as far as synchronization of data that I was referring to in the talk. Here's the mandatory slide. Your feedback is important to us. And I say this a lot, and I'm going to keep saying it. A year ago at PDC, when we were here, and we had SQL Data Services, which was an entity-based model, it did not look like it does today. And the reason it looks like it does today, and the reason we have full Transact SQL support, and the reason that you can take SSMS and connect up to a database in the cloud is based upon your feedback. We honestly take it, we listen, and whatever you guys come back to us and say, hey, I want this, we actually go ahead and listen, and we do it. And if it wasn't for your important feedback, we wouldn't be here where we are today. So please, please, please fill out your eval forms, email me. You can find me pretty much anywhere. We want to hear what you guys have to say. Also, there's plenty of stuff going on Channel 9, great resource for developers. And then if that's about it. So if you guys have any questions, I'd be happy to answer. That's it? Okay. There's mics in the back, yep, go ahead.
I've heard it's not possible to get the size of a database pragmatically. Is that true? And if so, will that be a new feature?
So yes, we don't have the ability today to programmatically get the size of the database. There are some interesting people that have posted some code samples out to kind of estimate what it's going to be. We're going to be having a rather regular rhythm of service updates. And one of the first updates that we're going to come out with will have the ability to programmatically get database size. I understand that when you're doing database partition, it's kind of important to know how big the database is. Worst case scenario, you can go out to the portal. The portal does have that information contained within it, but programmatic access to it, not today. It's coming very, very soon. Very, very soon.
Hi, is there going to be support for databases over 10 gigabytes?
Absolutely, yeah, absolutely. I can't comment on the size, but we've been saying it all week and we'll keep saying it. Very shortly there will be increased database sizes. It's definitely coming, yes.
Okay, thanks.
If you pop down and go to the SQL Azure Tips and Tricks Hands-On Lab, hope the labs are a little more quiet now, there's at least some detail that you can pull out of the master database in terms of your bandwidth in and out and the number of databases you're using that may at least provide some utility for you in terms of working out what you're going to be paying and how much you're using.
Sir?
A question for the ticket guy.
Come on up, Chris.
Yeah. First, I hope it's a kinder, gentler ticket service that doesn't have service charges and convenience charges and service convenience charges. But that's kind of an aside. The second question is, you partition things by venue, and it sounds like you may have as many as 100 different partitions. So do you use that technique that was described in the talk in order to be able to show which tickets? Because when a customer comes in, they're not saying, I want tickets in section 107. They're saying, I want this category of tickets, which I imagine could involve you having to query availability over multiple partitions.
So what we do is we have some customers who'll come in and say, I just want an A-grade ticket with a good view, right? And we actually have sort of pseudo indexes that we keep in memcached that we can then run around and go, where do we think we can get tickets? Go to that database and try and get them. And we actually groom that memcached data with worker roles, right? But for the most part, our customers do actually want to drill down to the section. We have a nice three-dimensional Silverlight venue viewer, and you can browse through the venue. You can see the various stands. You can click in the stand. You can see what's the view like from those seats, right? So we do actually provide both of those models, but we do a lot of work pulling stuff out into memcached where it does not necessarily have to be real-time transactional. But at the end of the day, bums on seats, real-time, has to be consistent data. We want that running in SQL Server.
And the cost savings you see from the database,
oh, I mean,
you pass that on to the customers.
Well, so we have a, I can't talk to the business model in too much detail, but Ticket Direct have a really exciting and interesting business model, and they're taking it up to the big American and Australian giants that played out in our region. So. We're the little guy, man. We're fighting for you.
Any other questions over here?
That was essentially the same question, how you deal with, like how do you find out whether there's any seat empty of a particular quality without doing a whole fan-out query?
Yeah. Again, caching, data grooming your cache. If it doesn't have to be absolutely real time, put it in the cache, right? Keep the load in your database being stuff that has to be transactionally consistent and durable.
This gentleman has a...
How do you deal with festivals or lawn sections where there's just a quantity that's very large quantity?
So the question was, how do you deal with festivals or lawn events where there's just a large quantity of tickets?
So what we'll do there is we'll effectively create pseudo stands and pseudo sections, which are basically just blocks of tickets that are hash coded into partitions.
This is a gentleman at the microphone in the back.
Given that SQL Server is very sensitive to whether data is in RAM or on disk for performance, it's a huge difference. And I'm wondering, with the 1 gigabyte databases, are you guys kind of loading these commodity machines up with lots of RAM, or do you have any comment on that?
Yeah, I can't comment on the specific hardware specs of the machines. I can say that we do a fair amount of monitoring as far as what the resources on the machines are and what the capacity of the machines are, so that if we notice the machine is getting hot, we'll start to offload some of those databases onto less utilized machines to make sure there's fair resources across all the different tenants of the service. But I can't really comment on specifics as far as resources of the machines.
Well, and related to performance too, currently I heard that I guess there's no DMV type support to see, say, average query response times on the SQL Server. Is that true? And if so, how soon are you going to get those kind of measures so you can find out how your queries are doing on the SQL?
Yeah, so we are working really hard to be able to provide things like Profiler so that you can actually see what's going on and see, get that type of information. It's one of those things that requires just a little bit of extra work on our part to make sure that we only return the results back to you for your specific queries. Since it is a multi-tenant system and we do have multiple people running on the same boxes, it's just before we go ahead and come out with these new features, we just need to make sure that all your data is sufficiently siloed.
Things like query profiler still work though, right? So you can, the query plan. So you can pull back the query plan. But yeah, no problem.
Thank you, sir. Up front.
How? Yeah. 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 How big is the apex?
The impact?
The impact. So again, at the end of the day, it's a reasonably low impact because we just trot around all of our partitions.
So hold on. I think the question was, at the end of the day, when the ticket sale is done, and they need to go ahead and take all this data across all these multiple databases and put them all back, into one sort of repository, what kind of an impact is that to the system?
Well, so we take the event offline for the period of time in which we consolidate that data, and we just go and run around the various partitions and just use SQL bulk copy to pull the data back together. It is actually, we have very small amounts of data in our partitions, like 1 megabyte of data in each partition. So when I said earlier we're partitioning for performance, we really are partitioning for performance. 1 megabyte per partition is not a lot of data.
Excellent. Question back there?
Will we see tools that allow me to see how my different partitions are performing, like relative to each other, whether I should probably partition more or maybe partition less? Because I think that's right now more a manual process.
Yeah,
or should I, in the end, rely on dynamic partitioning, which you alluded to that you're going to implement?
So right along the same time as we have some of this additional partitioning support, you will have things like Profiler. So you will be able to get metrics into how all your databases are doing as far from a performance standpoint. So you would use a tool such as that. Question over here on the left?
The code you were showing for doing partitioning in the application sort of took me back many years to the code you had to write in an application before databases knew about partitioning.
Mm-hmm.
So when will SQL Azure understand and support partitioning across SQL Azure databases?
So in vNext of SQL Azure, as we've discussed in the future session, we're going to be doing a ton of work to actually make a lot of these things transparent to you. I'm not guaranteeing you're going to have completely transparent database partitioning, but we're going to be pretty close to that point. So we understand that, if you think about it, and yes, you do bring up a point that, this resonates with a lot of people that have been in the database industry for some time, that, hey, this is what I used to have to do, 10 years ago. Why do I have to do it again now? And we understand that. It's a V1 product, we've heard the feedback, and that's why we're going ahead and prioritizing certain features such as partitioning, so that you won't have to go ahead and do that in the future. So, understood. Thank you, sir. Over here on the right?
Question. Is Microsoft going to be the only vendor providing a Windows Azure cloud, or are you going to open up that to other vendors?
The question is, and I'm really not the right person to answer that question. I will say that I've heard many times out of Mr. Ballmer's mouth that we will be offering this software out to other people. And you kind of got a glimpse of that in the keynote when we start talking about the Windows App Fabric and things of that nature. So I can't really comment on it except for my speculation is probably, but that's just a lowly program manager on a product team, speculating.
Okay,
so,
thank you.
No problem. Any other questions? All right, so Jeff is coming up next in about a half hour. So if you guys want to hang around and stay for that, great. Otherwise, have a great day. Enjoy the week.